那今天早上的第一场 keynote， 我们请到了 AMD Radeon 绘图技术事业群 VR 部门的总监 Daryl Sartain 来为我们进行分享。那 Sartain 在技术研发、IC 产品开发与管理、软体开发、系统设计与工程、资讯科技、市场行销和计划管理都有非常深厚的业界经历。今天的演讲 ，AMD 的 Daryl Sartain 将为我们从 XR、AI、区块链等不同的面向来探讨各种创新技术对游戏产业的冲击，以及对应各种创新技术所需要的硬体发展。让我们用掌声欢迎 Daryl。
Thank you. Good morning. Can everybody hear me? Yes, good. Let me get this back here. So thank you for having me. My hope today is to talk about some of the influences that we see in the gaming industry, and how those influences or how those changes and trends in the industry will affect or can affect developers, both positively and in some cases just simply the need to be aware of these trends, the need to include some of these trends or some of these technologies in your developments. So to start, I do want to point out that as I go through this, the perspective that I have, the perspective that we have as a company, AMD, is from a hardware standpoint primarily. From your standpoint as developers, you of course will have different priorities, different perspective, but it's critical that we understand together as an ecosystem, we understand what your needs are and that you understand what our capabilities and opportunities are for integration, for speeding up solutions and so forth. So a lot of what you'll see here is very much from that standpoint of hardware evolution and how we see that influencing your developments and your decisions. What I want to talk about today is a set of technologies that are both in the industry, but also that have direct impact or opportunities for impact in silicon or in our hardware, and how we see those being leveraged, how we want to work with the ecosystem with you to implement these across as they evolve, as they become mainstream solutions. So the immersion technologies, and there's many different definitions for this, XR, all of VR, AR, mixed reality solutions, high dynamic range. Certainly artificial intelligence and machine learning are becoming much more mainstream. And then of course blockchain. And I'm curious if I could ask a quick question. How many people here either have today or are planning to use blockchain type technologies in your environment, in your gaming solutions? Anybody? No? Okay. There's one. All right, we have one person. Okay, so let me give some background first. So the gaming industry today continues to grow. That's good news. So there's continuous growth, ongoing projection of 6% growth annually across the global market for gaming. I don't think this is a surprise to this market, to this group, but because of this type of growth, that enables us from a hardware standpoint and from an overall industry to continue to invest. And that investment comes in the form of different types of hardware and different types of opportunities for speed and optimization. Many of you here have been in this industry for a while, And a point that I think is critical is to understand that for a number of years, clock frequencies would continue to increase. But about, 10 years ago, roughly, 15 years ago, we reached a plateau for clock speeds. And it's not a permanent plateau, but the speed increases that we could see every year in our CPUs or in our GPUs rapidly came to a stop and became a flat line. So, as a solution, the way to continue to gain performance from hardware was to change the number of processing cores, whether it's a CPU multi-core architecture or GPUs with multiple shaders, multiple graphics cores. So again, it was a matter of addressing a particular problem in the industry by, if we can't go faster on clock speeds, we went to more engines, more simultaneous operations. What I want to talk about today is that even the increase, even the addition of more cores won't always solve the types of problems that we now face, or the opportunities that we now face with new technologies, new areas such as artificial intelligence or XR, immersive technologies. So how then do we go forward with a solution, a hardware solution, but a hardware solution that meets your needs as an industry? And to that end, some specialized tuning, specialized operations are critical to moving to the next phase of development. And by that, what I mean is we are focusing and continue to focus on specific optimizations around artificial intelligence, around blockchain. If you aren't using blockchain, certainly you're familiar with how blockchain has been used in the industry the last number of years. Mining and so forth. Now here's an interesting point. I'll talk about this a little bit later, but an interesting point about blockchain is that if many people believe that blockchain itself means crypto mining. Actually, that's just one application, and it's a niche application. The opportunities for blockchain in your industry are quite large. Lots of different benefits that you can derive from integration of this type of technology. We happen to have a very, very successful architecture to address that type of need or that type of processing of the blockchain algorithms. But also, we'll talk about FreeSync, high dynamic range. I'll talk about the immersive technologies, XR technologies, and then of course, ray tracing as a hardware accelerated solution for better image quality and better realism. So, very quickly as I go through this, I did this in order to give you an idea of how each of these tie together and what we'll be talking about. But I'll talk to artificial intelligence, blockchain technologies, FreeSync, high dynamic range. So FreeSync being the rate adaptation technology, XR technologies, and then of course ray tracing. So let me then move into artificial intelligence very quickly. AI or machine learning in the gaming world, you can use it in many different ways, and many different games today already use this. But opportunities such as autonomous behavior of characters, of non-playing characters, or adaptive rendering, which adaptive rendering is a newer opportunity, but it's an opportunity potentially to give a greater depth of realism in the game with a lighter development effort. So, what exactly do we do? Again, from a hardware standpoint, we focus on how to make the hardware optimized around these algorithms, these engines. So we have a product line called Radeon Instinct. Instinct is simply a name that we put to the hardware platform and the software platform that's tuned around the artificial intelligence algorithms. And with that, again, just briefly in terms of the industry, AI truly is being adopted and leveraged across every industry that I'm aware of, and more recently in the gaming industry. So we're beginning to see more and more interest, more and more development, and some of what I'll talk about here is that there are developments that, or actually there are announcements that will be coming out here in the next few weeks, which sadly that means that some of this I cannot talk to today, but there are some partnerships and some developments that are going on in the gaming industry around AI that are going to be very interesting for this industry and for how this gets leveraged into the gaming or into the user's experience in the gaming world. From a platform standpoint, because AMD makes both CPUs and GPUs, we have the opportunity to tune and optimize both. And we have a unique opportunity because we're the only supplier actually who has both architectures, both main processing units in the system. AI and other workloads, actually you'll see this with blockchain as well. Any type of algorithm that is heavily parallel in nature, oftentimes we find that those algorithms run quite well. They can be tuned quite well for a GPU type of an architecture, whereas serial operations are better tuned or better performed on the CPU. With our architecture, something what we call this heterogeneous computing essentially allows us to have this unified memory architecture where both our CPU and GPU can communicate seamlessly with each other in shared memory space or in a unified memory space. And again, all of this came out of the need to perform better, perform faster, or fewer, less latency, less memory operations and so forth. So that's what you'll see as we go through this is that from a system standpoint, we've taken these steps and our goal is to make those available, make access to those type of operations available to you. And that's where our ROCm, wrong button. I have to go back, sorry guys. So that's where our ROCm architecture or software stack comes into play. I'll put some slides up at the very end that talk to where the portals, the web portals are for the SDKs and the information on each of these. From an architectural standpoint, again, I'm not going to go into a lot of deep detail here. I'm not the actual engineering expert on it, but from an AI standpoint, machine learning standpoint, the software flow down to the GPU, we have a full stack that leverages existing frameworks for AI. And the goal here is with this MI open, MI simply means machine intelligence. So again, you'll see the same theme from AMD over and over. Our objective is to have open standards, open drivers, open development environments for you to make the industry as available as possible so that when you develop something, it can be leveraged across all architectures, ours and our competitors. So the MI architecture allows you to then take these frameworks and optimize them to the GPUs, to the hardware directly. And so again, within that, you'll see that we've got a couple of frameworks that I mentioned here, different runtimes and so forth. And so the terms, this sheet really is up here so that you can get a sense for what our terminologies are with HIP, with MI open, ROCm and so forth. But all of this is available in our GPU open portal where we post all the documentation, all of the SDKs and so forth. Essentially, what we're doing here is we're looking at how do we engage with the gaming community, and of course with all of the other industries that are leveraging machine learning or artificial intelligence. How do we engage with you, and more importantly, what features do you need? How do you intend to use AI in your gaming architectures? So as we go forward, that's what my team, that's what a lot of our groups out here are doing, is is working directly with the ecosystem to get a sense for the desire, the needs from the industry. Okay, so specific to the gaming industry. So AI, everybody knows what that is, but it's very specific to the gaming industry. There are a couple of key elements that we see developing or in some cases already in play. This adaptive rendering. Adaptive rendering is an area that we see a lot of research, we're doing a lot of research in, but there's a lot of work going on around the idea of providing macro commands, instead of providing all the details in a game, all of the depth of field, far field rendering. What if you can have AI with some macro commands render a background field essentially autonomously or automatically? Now, the truth is, we don't know yet whether it's more efficient for you to code the entire field or to use something like AI and have it automatically render some of these field background elements. But that work is going on, that kind of research. And it's not just research from us, it's many different companies. Non-playing characters, there's actually a number of examples of that in the industry already. Again, the beauty of non-playing characters is today they don't interact with the user, the game player. But with AI, they can actually interact or they can actually react to environmental stimulus. And then other examples of use cases for AI or machine learning in the gaming world. For immersive technologies, just the simple headset tracking, the ability to do SLAM, to do positional identification, location, and tracking in real time. And more recently, some areas of development around lighting, color rendering. So if you are developing for AR, augmented reality, one of the concerns you may have, or you will have, is when you develop a game, the lighting in that game is predetermined. You decide how you want the game to look. But when you have an AR environment where the user is also seeing some of the real world, and the lighting conditions in that real world will vary. They're different for every use case, for every user actually. You know, if somebody's got a bright room or a dark room, well now your game, your content no longer matches the environment that you're trying to overlay. So the idea of using AI in a fashion where you can adapt your game lighting, your game shading and so forth to that of the environment is crucial for user experience. Okay, I'm going to pick it up a little bit. So moving from artificial intelligence into blockchain, couple of, so I asked earlier how many people are using this. There's one. That's good. But I do want to talk just briefly about why we think it's important for gaming. Game distribution and tokenization. If you've not heard the term, I will say that it's a fairly recent kind of terminology that people are using, I believe. But essentially, in the blockchain environment, you know, blockchain itself can be used for virtually anything. And let me actually jump to the next slide here. As an architecture for secure transactions, secure tracking, secure identification, blockchain has applications across pretty much every industry, which includes gaming. And very specifically, the reason it includes gaming is, and I'll talk about this on the next slide, there's the opportunity not only to secure how games are sold and managed once they're released, once you publish a game, but also where the revenue, where the benefit comes into on the game itself. Because of our architecture, we actually have a very strong position in the blockchain architecture, blockchain industry. And again, the term most people are familiar with is crypto mining, but the underlying architecture of that mining industry is blockchain algorithms. And our architecture is extremely well tuned to support that type of a design, or that type of an algorithm, rather. So, as we look forward to the use cases here, just like what I talked about with AI, blockchain has a desire, a need for optimization, for speed enhancements. In our case, we have a particular architectural benefit because we do have both CPU and GPU technologies in-house. So the ability for us to both speed up the parallel algorithms of the blockchain engine itself, as well as the command structures of the calling, the game or whatever environment's calling the blockchain, we're able to tune that very seamlessly and link the two together in a particular fashion that doesn't require new silicon architectures or new speed barriers to be broken in the hardware. When we look forward to how this applies to gaming, to you, there are developments, some of which will be announced in the next couple of weeks, I believe. Actually, maybe even as soon as SIGGRAPH next week. But those developments focus on ways of leveraging blockchain for content distribution, for securely distributing your content, for having an architecture that ensures ownership, ensures traceability, trackability of who purchased, whether that key is valid, whether that key is well, in truth, whether that key perhaps was stolen or is what we call gray market key. But there's another opportunity, this tokenization. So tokenization basically, at least as I understand it today, is in a game, and you do this already, games do this already. When I play a game, I can earn credits, I can earn value within that game. But that value, those credits are generally limited to either that game, to a very narrow set of opportunities as a player, as a game player. The reason is because there's truly no secure manner for you as a developer to associate anything that I earn within that game as a player directly and securely associate that with me or with my account. Now there's a lot of arguments about this. There are ways of identifying because of my user ID, because I logged in and all this stuff. But through gray market codes and so forth, much of that becomes questionable. Turns out with blockchain technologies at a platform level, you're able to securely identify and secure or directly associate a game code as being valid, as being associated with an individual, a consumer, a registered owner, but also anything that they do or earn or gain within that environment is traceable and trackable directly to that person, and it becomes a much greater value for you as a developer to build trust, to build value for the users, because then you can start tracing what they're doing, not just across one game, but if you've got multiple games, or ensure that their codes aren't being stolen and used by somebody else. So, as we look forward, one of the things that we see in development, and you'll hear more about this over the next few weeks, is not just the user earning credits within a game, but also when somebody resells a game today, generally that does not involve the publisher. So you make money when you sell the game the first time, but if I finish playing, if I choose to sell my game, you don't make anything from that. One of the benefits that we see coming out of blockchain is the ability to actually trace ownership for the life of the use of the game. So if I choose to resell my game, that's fine. It's allowed, but it also means that you as a publisher share in the revenue of that resale. So you make ideally, you would make money not only the first time, but each time the game might be resold. And since it's your IP, I think that's a good thing for you. So again, you'll see more about this as we go forward in time, but giving you a preview of some of the things we're looking at. Now, from blockchain, let me move into this FreeSync and HDR. FreeSync is an industry standard. It's based on an industry standard of this adaptive frame rate or frame rate adaptation solution technology. And I've got some video here, so I won't talk too much about it because I think the videos give a better representation of what we're doing. But let me ask one real quick question. I asked about blockchain. Let me also ask, how many people plan to or are currently using high dynamic range, HDR, in their development? Anybody? Okay, that's interesting. So, much like high resolution games in the past, we believe HDR is going to give a whole nother level of experience and value to consumers. So there's a lot of development going on today around HDR, higher content quality, deeper, richer colors, and so forth, and I'll touch on that. But let me start with this FreeSync solution. So I'll show you these videos very quickly. What you'll see is, if you look at the image on the left, this one says image stuttering and no stutter. So if you watch elements of the video, in particular items that are up close, like this wall, what you'll see as the video loops, on the stuttering side, you'll see the image is not very smooth. Whereas on the right-hand side, the image flows very smoothly. In the next slide, I'll show you here. So that's FreeSync. This is also FreeSync. This is more about the image tearing. So again, on the left side, FreeSync is turned off. On the right side, FreeSync is turned on. And what you'll see is image tearing. You'll see image tearing across this left-hand side, whereas you will see no tearing on the right-hand side. This is all handled through hardware. It's very seamless. The benefit is directly applicable to the users. They experience a much greater video game experience because they're not disturbed by, or they're not interrupted by, images jumping around or tearing in the middle of the screen. One of the more recent announcements that we made is, not only have we been very, very successful in getting this type of technology adopted in the PC gaming industry, but very recently with Xbox. So we now have FreeSync in the console game industry because, again, the benefits are directly applicable to the user. And just to give you an idea of the reason, so what FreeSync allows, or what adaptive frame rate allows, is when you create a game, you do not know what type of hardware, what kind of a GPU or CPU the user will use when they play the game. So you design the game with a certain experience, a certain quality in mind. But if somebody, depending on what platform they're using, they may not achieve the frame rate that you want. FreeSync and this type of technology allows the GPU itself to take control over the monitor, rather than the monitor running at its own independent rate. And by doing that, the game you created, even at lower frame rates, will end up giving a great user experience. So this is the reason for this type of development from our side, from our business standpoint. Today we have in excess of 400 displays that are certified with FreeSync. It's the largest ecosystem out there, and it's very nice because, just looking at the name, It's free. It's free, but it's also extremely visible, noticeable benefit, okay? Now, let me talk about HDR. Again, I didn't see a lot of hands go up. Hopefully next year, many of you will be doing HDR developments. But high dynamic range, again, it's a question of whether, clearly, by the way, if you develop a game using HDR, using a wider dynamic range, the user needs to have an HDR monitor in order to experience that. Now, FreeSync and these types of technologies allow for operation, if you develop with HDR, that same game will play seamlessly on a standard dynamic range monitor. But keep in mind that at some point, HDR will be the standard. It will be the common experience. There will be no low dynamic range or standard dynamic range content eventually, because this is just the normal progression of content. So in time, you'll see that from a FreeSync 2 standpoint, so this is the evolution of FreeSync itself, we've worked with the industry, with the ecosystem to enable and drive a wider dynamic range even than sRGB, and again, all based on industry standards. So our work largely is helping the industry to certify and verify their solutions, their monitors, their hardware architectures, that they work well with these standards. So the result, of course, great pixels, easy plug and play. So the goal of FreeSync today, at least, so there's FreeSync and FreeSync 2. The goal of FreeSync is it does not require any changes or any support, direct support from the game itself. Everything that we do with FreeSync is handled in hardware between the graphics card and the monitors. In the case of FreeSync 2, you'll see here in a moment that there is something, because of the HDR, there is a need or an opportunity for you to develop higher quality, higher dynamic range content. But that API, that SDK, is available from us, and we'll be working with industry partners to make that happen. This low frame rate compensation is what I described a moment ago. If somebody's playing a game on hardware that maybe the frame rate that they achieve in their hardware is lower than what you wanted when you designed the game. So the options are that the user will experience a low quality, stuttering of the game, or through something like FreeSync 2, we can, with the right interface or the right cooperation with monitor vendors and certification, we can ensure that through hardware acceleration, through hardware in the monitor and handshake with our graphics card, that that content that's rendered at low frame rates is actually frame doubled or tripled to give a seamless or a smooth playback experience, what I showed in the video a moment ago. So again, very much our focus in all of this development is gaming. The FreeSync ecosystem is all about gaming. And how do we, and in the case of FreeSync 2, so you'll see here FreeSync and FreeSync 2, both are very much the same, except the low frame rate compensation with a very wide frequency range is something we've added with FreeSync 2, high dynamic range with FreeSync 2, and then of course from a development standpoint, from your standpoint, FreeSync, sorry I can't see it from here, FreeSync does not require any additional integration on your part, whereas FreeSync 2, the additional work really comes in the form of dynamic range. So we have an SDK that we have in our on our portals, but essentially it's an opportunity for you to start developing now with wider dynamic range. Those monitors are coming. We are certifying FreeSync 2 or HDR monitors quite quite rapidly these days. So there's a great deal of effort going on as we march into this next year. All right, so let me move then to XR, to VR and AR and so forth. This industry, so just from a hardware standpoint, all of our CPUs are VR ready. VR premium or VR ready as defined by the industry partners. Our GPUs, we have a wide range of GPUs that are also VR ready. Now in the case of GPUs, because we have GPUs that range all the way down to integrated graphics, of course, many of those don't meet that criteria to hit the 90 frames per second or the 70 frames per second. But we have a wide range of products that are certified for VR ready. In the VR space, however, what we're seeing today is lots of different features, and a lot of the work that we have done, we have collaborated to have much of this technology directly integrated into things like DX12 so that they become standards that simply get leveraged when you develop in that environment. I will talk in a moment about True Audio Next, which I have a lot of passion for, but all of these things, so asynchronous shaders, again, let me give an example. Asynchronous shaders is a hardware solution that addresses a particular problem, a particular opportunity, I guess, in VR. And that is by having a piece of silicon that can run independent, asynchronously, from the rest of the graphics engine, we can leverage that asynchronous shader architecture to process certain algorithms, certain elements of the pipeline, the video pipeline for VR. And by separating those out, we allow the rest of the graphics engine to render the environment, and then the asynchronous elements, the asynchronous shaders, essentially allow us to extend call it a frame boundary, so that we can have seamless playback with a wider range of graphics engines, okay? I'm not going to go through each of these because there's a lot of detail here, but I will say that the industry in general, some of this we have led directly, some of it has been an industry development, but there's been an awful lot of optimization in the VR space. And so who here is developing or has developed around VR? Well, okay, that's good. So the interesting thing about VR, and then I'm going to move on, the interesting thing about VR is that because the resolution is high and the frame rate is very high, you have very little opportunity to miss frames, to miss rendering. And so much of what you see here and what you see in this industry in general is, from a hardware standpoint, is designed to address those particular problems, those particular challenges. I mentioned earlier that we have much of our content and our development environments as open source or open standards, open SDKs. So we use this GPU open portal as a location for much of our content, including artificial intelligence and our VR, DX12 and so forth. So a lot of what you'll see here today will be available or is available in this content portal. All right, so last subject, ray tracing. Now, I have to be honest, I'm not a ray tracing expert, so I'm going to do my best to wave my hands. However, there is one piece of this that I do have a lot of passion, a lot of history with, and that is audio. Ray tracing is generally thought of by the industry, by most people, as a graphics function. Or in the scientific community, maybe it's thought of as a scientific, an analytical tool. But in the gaming world, it's considered to be a graphics function. And that's true. So when you look at this, ray tracing brings a number of benefits from a hardware standpoint For us, the benefit, or actually for you, the benefit we're trying to bring to you is for anybody who develops content both for consoles and for PC, things like some of the engines or some of the SDKs we have around ray tracing allow for bridging of content between different platforms. Because different platforms have different hardware capabilities, different user experiences. But let me go into some of the more interesting areas, which is, I mentioned earlier this idea of having an asynchronous engine. So what we've done with our ray tracing is we've taken the ray tracing algorithms themselves and made those available. We've ported that to our asynchronous engine within the graphics world. So now we can render, we can generate the ray traces asynchronous from the implementation. And what that means is that if you choose to use ray tracing in your game, whether it's for video or you'll see in a moment for audio, you can generate the ray vectors, the ray traces themselves asynchronously. In other words, you're not using the game engine itself. You're using an asynchronous operation within the game to do that. But what does ray tracing afford you? From a graphics standpoint, you can have ambient occlusion, right? You can essentially generate rays or the image based on the ray tracing. You can generate this type of occlusion result. You can have reflections, you can use the ray tracing to generate proper reflections of your objects. And of course, refraction, okay? So anybody who's used ray tracing or anybody who's familiar with this type of development, this won't be a surprise to you. What I find very interesting and very exciting is the opportunity to actually use ray tracing for audio. Now, perceptual audio, surround audio, is very much more of a VR benefit, I would tell you, than it is just a flat screen experience. And that's because perception of your head, everything that you do when you turn around, is tracked. And so when you do perceptual audio in VR or AR, the user experience is very, very good. To do this, there's a convolution algorithm for audio that has to be processed. We've worked with Steam. We've had our hardware accelerated audio in the Steam engine, Steam Audio, since Beta 13. We are now seeing ray tracing support from Embry coming, and so the result of this is with the ray tracing algorithm or asynchronous ray tracing engine, we can now generate ray tracing and associate or leverage ray tracing to our True Audio Next, to our audio algorithm, audio convolution engine. And so we can do, as with video or graphics, we can do reflections, we can do absorption, different types of environments. So all of that's part now of our development environment around audio. So to wrap it up, and I'm getting close to time, but to wrap it up, all of these technologies, each of these technologies appear, I would tell you, they appear to be very different or distinct from each other. The truth is, from our standpoint, from a hardware standpoint, they all apply directly to your industry. They don't just apply, but it's necessary for our industry, for us as hardware vendors, for you as content developers, it's necessary that we leverage what we can, since we can't increase clocks forever. We must focus on the user experiences, and that's what each of these represent in one fashion or another to your industry. So I think we're going to leave some of this stuff for later, so you can, we'll have make this available. But at this point, I guess let me take questions. Oh, sorry. Are there any questions?
我们现在开放做 Q&A， 然后我们现在走到两侧会有摆有麦克风，如果有问题的观众的话，就可以直接走到麦克风前发问。那如果你的问题是中文的话，也没有关系，我们的翻译老师会把你的问题翻译成英文。好，就是如果说对于刚刚以上的演讲有任何问题的话，都欢迎就是直接走到麦克风前做提问即可。
Oh, come on. Somebody's got a question. Don't be shy. Really? Okay, you guys are embarrassing me. You want me to ask a question? Okay, I can't ask myself a question. That'd be stupid. Yeah. Well,
如果有问题的话，我们可以直接走到后方，走到上有那个就是麦克风。然后。
Oh, sorry, the slide. Can you move the next page? We didn't capture the slide. Yes.
Oh, yeah. Okay, so that was your question. Yes.
Yes.
There you go.
Thank you.
Yeah, okay. Yes, I can. All right, any questions? Okay. Well, thank you very much for the opportunity, and I hope this was helpful. But I do appreciate the opportunity to speak and your time to listen to it. Thank you very much.